Hello everyone, welcome to MAC1140. So in the previous section we already talked about quadratic function, and we know that quadratic function has three terms. Sometimes we call it trinomial, right? And we also know the highest term in quadratic function is the second degree. And I also mentioned that for the linear function, the highest degree is the first degree. So if a function, the highest degree is the second degree and contains three terms, then we call that quadratic function. Now, what if the highest degree is not the second degree? And what if the function that contains as many terms as possible? So what is that called? What if the highest degree is the fifth degree and it contains a sixth term? So what is that called? So in that case, because it contains many terms, in that case we call that polynomial function. So that's why quadratic function we call the second degree polynomial function. So in this video today I will be talking about polynomial function, okay? And let's see what the domain of polynomial function and what is so special about polynomial function, okay? So let's get started. So I'm going to put the topic over here. Polynomial function. All right. Okay, so polynomial function also has two forms. The first form, it is a standard form. Okay, standard form of polynomial function. So this is what it looked like. So I have let me use this color here. So polynomial function, it looked like f of x equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a sub n minus 2 x to the n minus 2 plus plus c sub 0. Okay, so we try to try to understand what does it mean over here, or the letter over here, what does it mean. So over here we see that because it contains so many terms, so I have to use ... and the last number here is just a number, and a sub n, a sub n minus 1, a n minus 2 here, it's just the coefficient. So that's why a sub n over here that attached to the x raised to the n, this is called leading coefficient. And the n over here is the highest degree. Okay, it's the highest degree, and n over here must be a positive integer. Okay, must be positive integer. It cannot be negative one, and it must be integer. So n over here, it tells you the degree of this of the polynomial function, the highest value, the highest degree in that polynomial function, in that expression. And the c sub 0 over here we call that y-intercept value. Okay, then from here we can get the y-intercept point easily, right? Because it tells you where the graph of polynomial function intersect the y-axis. Okay. Let's see what else we should talk about this form right here. And the x here, you know, the variable x, I just want to mention one more thing. This the variable x cannot be under denominator. Okay, the a sub n, because a sub n, a sub n minus 1, a sub n minus 2 is just a coefficient, so it could be a positive or negative. However, all the exponent cannot be negative. Okay, so I'm gonna put a remark over here. Put a remark real quick over here. Is that exponent exponent can be negative. Okay. All right. Secondly, variable x, okay, can be in denominator. All right. Okay, so that is one of the conditions to determine if it is a function, is a polynomial function. Otherwise, it can be a polynomial function. Okay. Now let me give you an example. Alright, so what if I have something like this? It's something with the quadratic, right? So I have something like this. Alright, so this, you see that this is quadratic. This is the second degree. Okay, second degree poly function. Okay, because the highest degree over here is the second degree, and you see the c value is this, right? This is the c sub 0 right here. Okay, and all of this is leading coefficient. Okay, all of this is, so this is so you see that because the second degree contains 3 terms. Okay, so that's why we call this the full standard form. So this form is full if it contains all the terms. What if it's missing one of the term? For example, in the second example over here, I have something like this: negative 4x to the 5th plus 3x to the 3rd minus 2x plus 5. Okay, so over here the highest degree is 5. So this is 5th degree poly function. This is 5th degree poly function. So usually if we have a 6th degree poly function and it's full, then it means we contain 6 term. But if you look at this, you see that we don't have the 4th degree term, right? And we don't have the 2nd degree term. So we're missing 2 term. So this one is non-full standard form of polynomial function. Okay, and so this is what it contains all 3 terms for the second degree. So this is full. Okay, so all of this is polynomial function. The a sub n value, which is a leading coefficient over here, is 2. This leading coefficient over here is negative 4, and all the exponent is positive integer. How about this one? What if I have this? Negative 2 over 3 x to the 3rd minus 4x to the 4 plus 5x. Alright. So the highest degree over here is the 4th degree, even though that this is one of the coefficient here is a fraction, but the leading coefficient over here is the leading coefficient over here. So a sub n over here is negative 4, and n is 4. So because n is 4, so we know this is a 4th degree poly function. And do you think this is full? You know, 4 degrees usually we have 5 terms, but we have only 3 terms over here. So so this is non-full. It's not full because it's missing the term. Okay, it's missing the term. Alright, so this is not full. However, even though it's not full, but it's still considered as the polynomial function. You remember the first time you learned a linear function. A linear function is y equal to mx plus b, right? That is called a first degree polynomial function because the highest degree is 1 and it contains 2 terms. Now, how about this one? Alright, how about this? What if I have 3x to the 4 minus 2x to the negative 3 plus 5x plus 7? Alright, do you think this is a polynomial function? Oh, let's check the condition. Oh, look at this. The exponent is negative. Because this exponent is negative, so this is not poly function. Okay, it's not poly function because the exponent is negative. Alright, so this is not polynomial function. Even though that the leading coefficient is 3, and then all the coefficient is good. So a coefficient is not a really big deal. You look at the the exponent. Okay, then in order to determine if this function is a polynomial function. Now, how about the domain? Everybody know that for a quadratic function, it's a second degree. The domain could be from negative infinity to positive infinity. So similarly, so for all polynomial function, so I'm going to put the second remark right here. For all polynomial function, the domain is always a negative infinity to positive infinity. Okay, domain is negative infinity to positive infinity for all poly function. Okay, for all of them. Okay, how about the range? Of course, the range I cannot determine. The range you have to go ahead and do a quick sketch using graphing calculator. But the domain, okay, a domain we can guarantee that it goes from negative infinity to positive infinity all the time. Okay. All right. So on the if the polynomial function, okay, if the polynomial function is in standard form, okay, it's kind of very hard for you to determine the intersection point. I mean, of course, sometimes you can, because you can factor them out. Because, however, most of the time, it's very hard for you, especially with the highest degree, you cannot find where the function intersect the x-axis. Okay, I'm not going to say that it's impossible. Okay, it might be possible. However, it's very hard to find the intersection point between polynomial, the graph of polynomial function and x-axis. You can find the y-intercept point easily because by look at the last number. Okay, if some of them is easy to find intersection point in standard form, but most of the time it's very hard to find x-intercept point. X-intercepting point between polynomial function and x-axis if it is in standard form. Okay, so I repeat it. So if you're in that case, so what we're gonna do? Because most of the time, in order to sketch manually, you have to find intersection point and y-intercept point also. Okay, so in that case, you have to be able to factor them out. Because if you can go ahead and factor them out, you set it equal to 0, right? And you can solve for x, which is the x-intercept point of a polynomial function. Okay, and the question is, how are we going to factor them out? How we factor them out? Okay, so we're going to use all the concept we already learned to factor them out. So that's why polynomial function, it can be in another form. It can be in another form we call the factoring form. Okay, and this is what factoring form look like. This is what it look like. F of x equal to a x minus z sub 1 raised to the m1 times x minus z sub 2 raised to the m2 times x minus z sub 3 raised to m3 times x minus z sub n raised to the m sub n. So what does it mean by m1, m2, m3, and z1, z2, z3 over here? So let's see how we're gonna explain it. Okay. Okay. What does it mean by those letters? Okay. First of all, the a value here is still leading coefficient. I'm sorry about this, the background. Okay. Leading coefficient. Okay. A is leading coefficient, and z1, z2, z3 to zn, it is called 0. So 0 is actually intersecting the x-intercept value. Okay. In other words, this is x-intercept value. This is x-intercept value okay, which is the intersection point. So from here we can obtain the intersection point between the graph, okay, between the graph and the x-axis. So you see that we have a lot of intercept point between the graph and the x-axis. Okay, so if you have all the z1, z2, z3, you can find all the x-intercept point easily. Okay, and in order to find the y-intercept point, you just need to replace x with 0. So everybody know that already. M1, M2, M3 over here. M1, M2, and here we call that this is, we call what? Anyone remember? Anyone remember that I already mentioned this in I don't know if I never mentioned. I'm sorry. So M1, M2, M3 over here we call the multiplicity. Yeah, I never mentioned about this. Multiplicity. Okay, and the multiplicity over here, it must be positive integer. Okay, it must be positive integer, and it could be even or odd. If it's even, then we know that the graph of this polynomial function will be touching x-axis. Okay, touching x-axis, and if it is odd, then will be the graph of the polynomial function will be crossing x-axis. All right. So most of the time, this is very, this is kind of very helpful form. It's just much better than standard form, in my opinion, because it's easy for you to find x-intercept point. Okay. Now, let me give you example. Okay, give you example. Example number 1 right here. So given f of x equal to 2x minus 3 raised to the second power x plus 1, and first of all I want you to find domain. Okay, then phi 0. X-intercept point. Okay. Then find multiplicity. And determine if the graph is touching or crossing. Alright. Let's see how we can answer this. So everybody know that for the domain of polynomials, so this is polynomial form, okay? Because the degree over here is positive, so everything is good. So for the domain is always go from negative infinity to positive infinity. Okay, and 0. Okay, 0. Okay, 0 is the value right here. So z1 will be 3, but z2 will be what? Because the formula is minus. The formula is minus, so z2 over here will be negative 1. Will be negative 1. Okay, will be negative 1. So z2 is negative 1. Because negative and negative give you plus. Okay, so from here we can find the x-intercept point. So x-intercept point over here will be what? Will be the first point will be in the order pair form will be 3, 0, and negative 1, 0. So we have only 2 x-intercept points. So what is multiplicity? So multiplicity over here is m1 over here is 2, and m2 is what? M2, what is the degree over here? M2 is 1. And because m2, let me put over here. M2 is 1. because M1 is 2, so we know this is even, and that's why it's even, so that's going to be touching x-axis. Okay, at where? At x equal 3. Okay, at x equal 3. At x equal 3. And this will be crossing x-axis. At where? At x equal -1. Okay, right here. At x equal -1. Alright. And that's it. Okay, that's simple. Right? Now, what if they want you to find y-intercept point? Maybe I'm gonna add a little bit over here. Another question. Find x-intercept point. Maybe part D. Part D, I want to find y-intercept point. Alright, in order to find a y-intercept point, you just replace x with 0. So you will have what? You will have y equal to 0 minus 3 squared. 0 plus 1. So go ahead and calculate them out, which is 2 times 9 times 1 will be 18. So the y-intercept point will be 0, 18. There you go. That's simple. Alright, that's it. Okay. Okay. So very simple. Very simple. Alright. Example 2. What if I have function like this? Okay. Oh, the a value over here. So the leading coefficient, the a value over here should be 2. Okay. Okay. The a value will be 2. Now, in the second problem, it will be a little bit different. Of course, because it's different, the a value also different. So here x 2x minus 1 raised to the third, x plus 2 raised to the second. Alright, so we're gonna find all the question here. Okay, all the question there. So the domain, again, the domain will be negative infinity to positive infinity. So I'm not gonna mention that much. So the z1 which is 0 will be what? You see, most of the time you will think that it's 1, right? But it's not this time. Because you see the difference between this and the formula, there's nothing in front of the x. See, nothing in front of the x. But now there's something, there's number 2 in front of the x. So in order to find z1, okay, in order to find z1, you have to set this up equal to 0 and solve for x. So x over here will be a half. So z1 will be a half. Alright, z1 will be a half. And z2 is easy. Z2 because there's nothing in front of x. So z2 is still -2. So with z1 and z2, we can find x-intercept point easily. Huh? So the x-intercept point will be a half, 0, and what? And -2, 0. There you go. Alright, so that's his x-intercept point. Then now we can find the y-intercept point over here if you want it. Y-intercept point. You know, to find y-intercept point, you're gonna replace over here with 0. So you have 2 times 0, 1. 2, 3 times 2, 0 minus 1. So you have 3, 2 times 0 minus 1 raised to the third. Alright. And 0 plus 2 square. 0 plus 2 square. There you go. Now we go ahead and calculate the minus. So you have 3, -1 raised to the third, 2 squared 4, -3 times 4, -12. So the y-intercept point will be 0, -12. There you go. Very easy. That's part A. Now we want to find multiplicity if you want it. Okay, find multiplicity and determine rapid touching or crossing. Okay, so M1 will be 3, right? 3 is odd, so will be crossing x-axis at x equal a half. Okay, and m2 will be 2, will be touching x-axis at where? At x equal -2. Here you go. That's it. Alright. It's very, very simple. Okay. Alright. Now, in the third example, okay, I'm going to show you how to write. Remember last time we learned how to write quadratic function using the vertex form, right? I'm going to show you in this example. I'm going to show you how to write polynomial function. Okay. Okay. Write polynomial function using factoring form. Okay. Write polynomial function which has 0. Okay. 0 is 2 and -3 at multiplicity multiplicity 1 and 2, okay, respectively. Okay, and goes through point. Goes through point. 1, 1. There you go. So let's see how we will do this. And again, in order to write polynomial functions, like last time we write a quadratic function, we never used standard form, right? We used last time quadratic function, we use vertex form. But for polynomial function, we have to use, okay, so we have to use factoring form. So factoring form is this: x minus z1, because there's only 2 0, okay, m1 times x minus z2 m2. Alright, so this is the formula. Okay, this is a formula. You know what? I think we're going to use different color. Let me rewrite it with different color so that, because every time we want to write function, we want to write a formula. So let me write with the formula. Okay. Okay. So we're gonna have y equal to a x minus z1 m1 and x minus z2 m2. So we have only 2 0 and 2 multiplicity. So this is a formula. Alright, so our goal is to find a. Okay, and because we already have everything over here. Okay, so now because we have everything already, we just go ahead and plug them in. So you have a x minus z1 is 2, correspondingly to multiplicity 1 over here. Okay, and z2 is minus, so minus minus become 3, corresponding to multiplicity over here is 2. Alright, now we want to find, in order to find a, okay, in order to find a, we need this point. We need this point. Alright, so we're gonna plug 1 and 1 into x and y. Okay, so plug it in. So we have y equal 1, a 1 minus 2 raised to the 1 power, 1 plus 3 raised to the second power. So you have 1, negative 1 raised to the first power is negative a. 1 times 3, 1 plus 3 is 4, this will be 16. So your a over here will be what? Your a over here will be negative 1 over 16. There you go. And from there we're gonna have a polynomial function f of x equal to what? Equal to a is negative 1 over 16, x minus 2. You gotta keep x, okay? Okay. The degree 1, so you can go ahead and throw it away. X plus 3 squared. There you go. That's final answer. Okay. Alright, so this is the last function we learned how to write. Okay. First time you learn how to write linear function, y equal to mx plus 3. You want to write, you already learned circle of equation. You want to write that. and you learn how to write a quadratic function. And now this is polynomial function, so you do not be mistaken amongst all the formula. Okay, so each of them depends on the question, what time they want you to write. You have to use different formula. Okay, you have to use different formula. Okay, so you have to practice a lot. Okay, you have to practice a lot. But this, you know, in pre-calculus you're gonna do it again with complex value. But I mean in calculus, in college algebra, this is very simple, something like this only. Okay. Oh. Okay. So so far we learned the concept of x-intercept point and y-intercept point. And we learned this concept so many times already, right? In all functions we go through so far. You know, we also talk about x-intercept point and y-intercept point. And I don't know if any of you ever ask yourself, like, why we have to know x-intercept point and y-intercept point? What is x-intercept point and y-intercept point for? The purpose of finding x-intercept point and y-intercept point is it helps you to sketch the graph, to sketch the function. Okay. Another information you need to know that help you to sketch the function, it is you want to know how the function going up or going down when x approach to positive infinity and when x approach to negative infinity. That concept we call the ending behavior. So for the third part of our lecture today, I want to talk about ending behavior. Okay, ending behavior, which is how the function behave when x approach to positive and to negative infinity. Right. So I'm gonna start this section, this part over here, by categorize into 4 different cases. It depends on the n value and a sub n. So that's why the n value, which is the highest degree in polynomial, and the a sub n, which is the leading coefficient. I'm sorry, which is the leading coefficient of a polynomial. This is very important. It helps you to determine ending behavior of a polynomial function. Okay, so let me split it up into the cases. Okay, so that you can understand better. So let's see. So I'm gonna have it something like this, I think. All right. So I'm gonna split it up like that. Okay, so over here I'm gonna put as over here n is even, and over here I'm gonna put n's odd. Okay. And when the case n even, okay, I'm gonna split up into 2 more cases. Alright, so 2 more cases. So over here I will have when a sub n is greater than 0. And over here a sub n is less than 0. Same thing over here. I'm going to split up into 2 cases. Over here a sub n is greater than 0. And over here a sub n is less than 0. Alright. Alright, so if a sub n is greater than 0 and n is even, the sketch of polynomial function will be something like this. Could be something like this. It's gonna be like that. For this one, will be something upside down, kind of the same thing, but it upside down. For n is odd, so we will have something. Let me make this a little bit longer. Alright. So when n is odd, so this is y. So n is odd, so we're gonna have n is positive, so we're gonna have something like this. And when n is less than 0, we have something like that. It's not a nice graph. There you go. Okay. Alright. Now, from this sketch, we might get the ending behavior easily. So, you see that when x approaches to positive infinity, right? When you started from here and you keep walking toward the right hand side. So when x approaches to positive infinity, what happened to the function is the function is going up, right? The more you go into the right hand side, the more the function going up. So this is y approaches to positive infinity. And when you start from here, you go all the way to the left. So when x approaches to negative infinity, right? When x approaches to negative infinity, you start walking to the left. The function is also going up. Alright. So that is ending behavior. Okay. The same thing over here. So make it a little bit longer. A little bit longer here. So when x approaches to positive infinity, and the function going down. Okay. When x approaches to negative infinity, the function still going down. Okay. When x approaches to positive infinity, going to the right, the function's going up, so y approaches to positive infinity. When x approaches to negative infinity, the function is going down, y approaches to negative infinity. Alright. Same thing over here, when x approaches to positive infinity, to the right, the function what going down. When x approaches to negative infinity, the function going up. There you go. So you see that the ending behavior will be obtained easily if you know, if you can determine the n value, which is, and also the a sub n. Then you gotta check it with in what case it will fall into. There are only 4 different cases right here. Okay, and from there you will get the ending behavior. So I mean, this sketch over here is very important. Very important. You need to memorize that if you want to, if you can. Okay, so try to memorize. It's gonna help you a lot to determine ending behavior. All right, let me give you an example. All right, so on this example, I'll give you polynomial function in as factoring form. Okay, it must be in factoring form. I have something like -2. 3x minus 6 raised to the 4th power. Okay, x plus 1 raised to the 3rd power. And for the first part, you want to find x and y. Okay, I'm sorry. Phi 0. Sorry, phi 0. Okay, and x-intercept 1. Okay, then I want you to find y-intercept 1. Okay, then finally I want you to find not final one yet. Determine multiplicity. Okay, and its location. Okay, and finally I want you to determine ending behavior. Okay, the first three questions is kind of similar to what we already done so far. But question number 4, I want you to determine N and B. Alright, so let's see how we do this. Alright, find 0. 0 easy. You see the difference is that over here the value in front of the x is not 1, so you have to set this up 0 in order to find z. So x equals 6 divided by 3 is 2. So z1 equal 2. Okay, and z2 is so obvious, so z2 is minus 1. Okay, so from here we can find x-intercept point. So x-intercept point will be 2, 0, and negative 1. 2, 0, and negative 1. 0. Alright. B. Y-intercept point is easy. In order to find y-intercept point, you can replace the x with 0. So you're going to have y equal negative 2, 3 times 0 minus 6 raised to the 4. 0 plus 1 raised to the 3rd. So you can have negative 2, negative 6 raised to the 4. And 1 raised to the 3rd will be 1. So you have negative 6 raised to the 4. It's a pretty big number. Then times 2. Oops. You have negative 2592. This is a pretty big number. Alright, so the y-intercept point. Y-intercept point will be 0 minus 2592. Alright. Alright, part C. Determine multiplicity. Very easy. So M1 is 4, and this is even. So it will be even. So this will be touching x-axis at where? At x equal to corresponding to that, right? The x corresponding will be 2, and M2 will be 3. Will be crossing x-axis at x equal y equal to negative 1 right here. Alright, x equal negative 1, and this x equal 2 right here. Okay, so that's multiplicity. Part D. Here you go. Determine N and B behavior. We need to know N value. Alright, so the highest value over here. The highest the highest degree over here, you gotta add this. So 4 plus 3 will be 7. So it will be odd, right? And a sub n, you just need to know it's a positive or negative. Okay, a sub n over here is 1 raised to the so this will be negative 2. Okay, so a sub n will be equal to negative 2. But because we had to consider this also, okay, so the leading coefficient here and leading coefficient here also, so 3 to the 4, it's 3 to the 4 times 1 to the 3rd. So definitely this one will be, this is the negative number, right? Okay, the value here raised to the 4, and the value here 1 raised to the 3rd. 3 raised to the 4, 1 raised to the times negative 2. So definitely will be negative. And if it odd and negative, odd and negative, so this is your N behavior right here, in this case, the fourth case. Okay, so N behavior will be when x approaches to positive infinity, y approach to negative infinity, and when x approaches to negative infinity, y approach to positive infinity. Okay, here you go. That's N behavior. Good. Very simple. Alright. Okay, let's just go ahead and delete this. Just example. Okay, so all the other example, I mean, if I give you something like this on a test, then I mean, at most I'm gonna give you something like this. Okay, I mean, change a little bit. I probably I change the number. I change the number over here could be 2 or 3 or negative, but I mean, kind of the same thing. Okay, all the question over here could be the same. All right, good. All right. Let's see anything else I want you to notice. For the sketching part, because all information is help you to sketch the polynomial function, but on the test I won't be asking you graphing this, because I don't see the point, because you guys have graphing calculators. So I mean it's good to know all the information here, but for the sketching part, I guess we don't need it. Okay, so I think I'm gonna stop the lecture over here. If you have any question, do not hesitate as asking me question. All right, and I'll be seeing you next time.